Hi all. So we're going to be looking at the AP Physics 1 sample problem from the College Board website. They've been doing these practice sample problems, online problems that you could kind of expect to see or something very similar on your AP exam this year. And these questions, they have solutions. If you haven't seen them before, I suggest you check out the College Board's AP YouTube channel. I'll put it in the description below, but they have been putting out a lot of great questions, a lot of great content, great instructors. They've been going through answer explanations, but some people have still been asking me if I can go through them, and I figured I would just make my own of how I would look at a problem, what I would write, how I would think about it. So let's take a look at this first. This is a QQT problem, so you're supposed to have 25 minutes for this question with and then an additional 5 minutes to submit your answer. So we have a passenger compartment rotating amusement park ride contains a bench on which a book mass MB is placed as indicated in the dot on the figure above. So it's going like this. The compartment moves with a constant angular speed about the center of the ride along a circular path of radius r. The bench remains horizontal through the compartment's motion. The right figure shows a magnified view of the compartment. The graph below shows the horizontal x component of the book's position as a function of time, where plus x is to the right. So it's kind of sinusoidal, which kind of makes sense. It's moving left, it's moving right, it's moving left. As it moves around, right, it's moving left. Then as it comes down this way, it's moving to the right, etc. Explaining briefly of the graph could be used to determine the period of revolution. Okay, period of revolution is when it comes back to its original point again. And so you see how it's very cyclical. The period is the time when the cycle the cycle repeats. Simplest way to do it is to measure it peak to peak on the cycles like this. Is the time it takes for the cycle to repeat. You can measure peak to peak. Okay. Can the tangential speed, not the angular speed, be determined from the information given? Briefly explain why not. Well, you can extract from the period. Period is 1 over f, and that's 1 over 2 pi omega. Okay, so you can calculate the omega by doing 1 over 2 pi t. Okay, so in words you could say you can calculate angular velocity from the period. And this is why I like having equations and being written out. It seems like when I was looking over some of the sample questions is that they're trying to make it to where you can type out the answers with just words and explanations, at least from all the physics questions there. The calculus ones are definitely not like that, but the physics ones seem to be geared that way. And the statistics, I think, are starting to be geared that way too. So you can calculate the angular velocity from the period. How do I determine the tangential speed? Is I use v equals r omega to find tangential velocity. Now, do I know r? Do I know the radius? Well, this is where I disagreed with the interpretation of this. They're asking with the given information, can you figure it out? When I first read it, I was like, well, you don't know the radius. And the reason I said that was like, they gave you a lot of numbers here, like on this graph, but then they only gave you variables here. So the question is are you given the information? They gave you a letter, but did they give you that information? I honestly, because it was a mix of numbers and variables, I wasn't sure if it was a given information. So I was saying, no, you would need to know the radius. But in looking at it, I think they meant to say that you did have R and MB. And this is the problem with this kind of wording, with the given information. Because in a normal Physics 1 exam, they would have probably asked you to come up with an equation that describes it using the following constants or something like that. But they couldn't quite say it this way because they don't want you to have to do a lot of equation manipulation. So they say based on the given information. I suppose the way you read this is you're supposed to read that even though these are letters and they didn't give you the exact number, it was technically given. But I find it a little confusing that they gave you numbers here, but didn't, like they gave you numbers here and then they give you some letters here. So like, it's kind of like, well, usually when I get numbers, I assume the numbers are given and the variables are not given, but like, I get what they were going for. So, but as long as you explain this, how you could get it. So my answer initially when I read this, I would have said you need R to figure out V. Okay. That was one way I thought about it. Anyway, that's what my initial response is. I think I probably still would have gotten credit if it was this ambiguous. I think it will be less ambiguous and the questions will be vetted more for the actual exam. Like, I think they'll do a really good job vetting the question, making sure it's like easy to understand. It's not ambiguous in that sense. But for this sample one, I did feel like because of the mix of the numbers, specific numbers, and the R, that they were leading you to like estimate it or try to calculate it or estimate it. Like if they're asked, because they give this a number, is like, well, how could I figure out T? I would just look at it and I could estimate the number, but I can't give you what V is because I don't know what R is, right? So I can't estimate a value for V. But anyway, I think I've harped on that long enough. What forces act on the book at the lowest point of its circular path? Indicate in words both the direction and source of each force. Okay, so bottom down here, what are the forces it's feeling, the book is feeling? Well, downward, it has a force of gravity, downward, and then it has a normal force going upward. So it has a force of gravity due to the Earth, that's the source, and I say it's downward. And then the force, the normal force, what's causing the normal force is an upward force from the bench. Normal force from the bench. Upward. Direct and to the point. What are the forces? Which direction they are. At the lowest point of the circular path, the book is moving only in the horizontal direction. 3 students are discussing the force of friction on the book. Here are the arguments. Student 1. At the instant the box is at its lowest position, the book experiences no force of friction at all because the net force is only in the vertical direction. Student 2. At the instant the box is at its lowest point, the book experiences a force of kinetic friction because the book and the bench are moving to the right. Student 3. At the instant the box is at its lowest position, the book experiences a force of static friction because the book doesn't slip relative to the bench. D. What is one aspect of students 2's reasoning that is incorrect? There is no kinetic friction in this case. Kinetic friction is not just when something is moving, but it's moving relative to the surface. Like if I had friction to the bench, you would need to have like the book sliding along the bench. Like there's a movement relative to the bench, relative to the surface. There's like this rubbing motion. So there isn't, and that's not happening in this case. So there is no kinetic friction because the book is not moving relative to the surface, the bench or surface. Basically, whatever object is causing that friction or that the other surface is rubbing against. Okay. Who is correct, student 1 or student 3? Let me read this again. Book experiences no force of friction at all because the net force is only in the vertical direction. Let's think about that one. At the next box, the lowest position, the book experiences a force of static friction because the book doesn't slip. So if I were to look at this object, I would say, which direction is its acceleration? Well, it's moving in a circular motion, right? Circular motion, it feels centripetal acceleration. The net acceleration is upward towards the center, right? Net acceleration is going to be towards the center of the circle because moving in a circular path, constant velocity. Constant speed. That's uniform circular motion. So the net force has to be upward, right? So if there were static friction, what would be counterbalancing the static friction? So there's no static friction, right? Static friction is a reactive force. It responds to a force to prevent an object from moving. So if there's no external force pushing it horizontally, there's no static friction. Like when I have my pen sitting here on my hand, there's no static friction because there's no force that's counterbalancing. If I try pushing a little bit but it's not moving, now I have static friction. So static friction is reactive. Like it has to respond to something. So student 1 is correct. What I explained is why student 1 is right and why student 3 is wrong. Okay. Student 1 is correct. The net force is vertical. Net F is vertical. It's called the centripetal force. I don't really like the word centripetal force, honestly. Don't get me started on the use of centripetal force. It's highly confusing to have such a word called that. But anyway, the net force is vertical. It is the centripetal force. And there is no horizontal. There is no external horizontal force. Thus, no friction, no static friction no static friction to balance it. Okay, that's all I would say for that one. At the lowest point of the circular path, the book is moving only in the horizontal direction. In what direction, if any, is the net vertical force on the book? We said upward. It is upward because the net acceleration is towards the center of the circle. This is uniform circular motion. That's it. And then F equals ma. By Newton's second law, if the acceleration is upward, the force must be upward also. You could say, by word, you say by, because they don't want equations on this one, by Newton's second law, a net acceleration upward means the net force is upward. So they really want you to type out. They're really encouraging you to just type out a little essay response. And they do that because it's easier to, it's easier to tell if you're plagiarizing an answer. So a student is asked to derive an equation for the vertical force FB that the bench exerts on the book at the lowest point in the circular path in terms of the book's mass, tangential speed VB, radius R, physical constant. Here's student's incorrect derivation. He did net force over M, acceleration's VB squared over R. The net force he did, that's MB, and that is FB. What is he says? FB for the vertical force that the bench exerts on the book at the lowest point. He just says that there's only one force, FB. One way in which his derivation is incorrect. The sum of forces should have been, like if you did a free body diagram, right? It's the force from the bench, or I called it the normal force and force gravity. The sum of the force, F, should have been FB minus FG. Okay, so the net force should have been FB minus FG instead of FB alone. Right? Because you got to do the net force, and we did when we talked about the forces. There's the upward force and downward force. Why do I do FB minus FG instead of FG minus FB? It's because the acceleration was upward, right? It's towards the center, so we make that our positive direction when you want to do v squared over r, because v squared over r is a positive quantity. So you need your sum of forces to be a positive quantity also, and thus towards the direction of acceleration must be positive, the net acceleration. Is there anything else wrong with it? I hate checking someone else's work. Even though I'm a tutor, I usually have to do it myself, and then I make sure. So if I were to derive it, I would say net force is FB minus FG. That's equal to M V squared over R. VB is tangential speed. R is the path. I think everything else is right. I don't see anything else wrong other than that part. So I think, well, maybe he just didn't solve it correctly. So M, he multiplied it by there. Well, I guess because you have this minus FG, you would have to add FG to that side. So, okay. At the lowest point of the circular path, is the force that the bench exerts on the book greater than, less than, or equal to the weight of the book? Must be greater. Because the net force is upwards. I don't know how many times we have to say this. It's kind of like we're rehashing the same thing. Also, another reason I don't like the question, because if you didn't really get that part of the circular motion, then you're going to lose a lot of points for not getting any of these right. So it's kind of like the same concept, you're just being hammered on. Because the net force is upward. Greater. Because the net force is upward, the FB must be greater than FG, or you could say mg for force of gravity, the weight of the book. FG is the weight of the book. Briefly explain how your answers in E and F support your choice. What do I do for E and F? E, because student 1 was saying that the net force is only in the vertical direction, and F is in what direction is the net vertical force on the book? It's upward. I don't know. Like we're like saying the same thing over and over. It feels like on this question, so I don't really know what they want you to say. We can just rehash the same thing that we're saying. We're in circular motion, and uniform circular motion, accelerations towards the center of the book. I don't know. It's kind of going upward as it's going. I don't know how many ways we can say that really. So I'm just gonna leave it like that. Hopefully you get it. My goal is for you to understand what to say. Consider the position of the compartment at the top of the path and at the bottom of the path. At which of these positions of either is the total mechanical energy of the book greater? Justify your answer. In your justification, either explain the source of the work done on the book which changes mechanical energy, or explain why the book's mechanical energy did not change. This is worded oddly. So let me explain why. When you say total mechanical energy, I always forget about this. But assuming we mean the gravitational potential energy and the book, assuming we mean the book-earth system and not just the book by itself. The book by itself only has kinetic energy, but the book-earth system would have kinetic and gravitational potential energy. So because he's saying the total mechanical energy of the book, does that mean, should I assume that he means gravitational potential energy is included or not? Because he didn't say the book-earth system, he just said the book. I know some teachers who are a little picky about that. I wouldn't be so picky about that. I would assume that that includes gravity, and I think that's what they meant by this. But you could make an argument that they're only talking about the book, and if you are only talking about the book, the only energy it has is kinetic energy. And if that's the case, how's the kinetic energy at the top and the bottom? Well, because it's moving at the same angular velocity, the kinetic energy is unchanged. Assuming if you assume only the book is in the system, it only has kinetic energy. Okay? So only has kinetic energy. See, because you need a book and the Earth to include gravitational potential energy in the system. Okay, it only has kinetic energy. Kinetic energy, which this depends only on the velocity. Or it actually depends on the speed. The speed of the object. The book. Because the book is moving at a constant velocity. Book is moving at a constant angular velocity. Angular velocity. The tangential velocity is the same. Is constant. Same rate, same R everywhere. At the top and bottom. Thus, no change in kinetic energy. Now, let's just say you thought, I'm going to assume gravitational potential energy. We should talk about that. So if you did make that assumption, you should include the gravitational potential energy. You should word it a little differently. Clearly, the kinetic energy didn't change, but the gravitational potential energy did increase. Okay? So what caused that increase? What added energy into the book Earth system to increase the gravitational potential energy? And that would have been the work done by the motor of the Ferris wheel to turn to push the book up to the top. And so that's how you would explain it if you were going to include gravitational potential energy. I honestly think you could go either way, and I think I personally would grade either answer correctly. I just think you should be very clear as to why you're only including kinetic energy, because it says only the book. And that's why I said assuming only the book is in the system. That's why I very caveated that. We don't include potential energy in that system. So anyway, I think these questions probably just weren't vetted super well, or at least like in an answer like this, they would have gone either way. I'm curious. I'll probably go check the video that they posted today of reviewing this question to see kind of like how they interpreted this one. But yeah, hopefully you found that helpful.